All right, so now let's go over intermolecular forces. I told you intermolecular forces are the forces that are between the molecules. There are three types of forces. You have temporary dipole, induced dipole forces, permanent dipole forces, and hydrogen bonding. Collectively, these forces are known as van der Waals forces. The weakest of all these forces is the temporary dipole forces, temporary dipole, induced dipole forces. Then is the permanent dipole, and the strongest of all three is hydrogen bonding. Now, why do we study about intermolecular forces? Because certain factors depend on intermolecular forces, like you have the melting point and the boiling point, you have your solubility, you have the volatility, and the physical state of elements. They all depend on intermolecular forces. The stronger the forces, the greater the melting and boiling point. The stronger the forces, the physical state would be solid. If you have stronger van der Waals forces, the volatility will be low, because the more the forces, the stronger the forces, the difficult it will be to overcome them, and the lesser will they be able to escape as vapor, because volatility is the ability to escape as vapor. And then you have solubility, which depends on hydrogen bonding. We have the weakest of the intermolecular forces, which is a temporary dipole, induced dipole forces. These forces are found in all molecules, but non-polar molecules only have these type of forces. Let's take an example of hydrogen with another hydrogen. So in this, we know that the electrons, since the electronegativity of both the elements is the same, electrons tend to be in the middle, but electrons don't remain in a fixed position. They keep moving back and forth. So if we were to momentarily stop the motion of electrons, electrons may lie closer to one of the atom, let's say this one. So when they lie closer to this side becomes partial negative, and the other side becomes partial positive. And what have we made? We have made a temporary dipole. Now, because this side is partial negative, this will repel the electrons in the neighboring molecule. And this neighboring molecule, the electrons will be pushed to the other atom, and the electrons go here, making this partial negative, and this side becomes partial positive. Do you see a temporary dipole has induced a dipole in the neighboring molecule? And this gives you temporary dipole induced dipole forces. And these are the weakest form of forces. Why? Because the dipole will be fluctuating. Once you unpause the movement of electrons, it will go back to it will go back, it'll revert. Yes? Now let's see another example. Chlorine, also we saw non-polar molecule, so this will have temporary dipole induced dipole forces. Then we have the forces in methane, how they are formed. We know that if we momentarily stop the motion of electrons, they will give a temporary dipole, which will induce a dipole in the neighboring molecule. Then we have a relatively stronger type of forces, permanent dipole forces. Let's see permanent dipole forces. Now this is between polar molecules. Let's take an example of HCl. In HCl, you see Cl is more electronegative. So the partial negative charge or the electrons will lie closer to Cl, making this partial negative. This side becomes partial positive. No matter what you do, the electrons will always lie closer to Cl, giving you a permanent dipole here. And then another HCl will also give you a permanent dipole here. And between these two molecules, you will have permanent dipole forces. These are stronger forces. If they ask you which type of forces will you find between HCl molecule, so you will say permanent dipole forces and temporary dipole forces, because temporary dipole forces are found in all molecules. Which, however, is a stronger one? The stronger one is permanent dipole force. Clear? Likewise, in HBr also we have permanent dipole forces. Now, if they say suggest the strongest intermolecular force in HBr, again that would be permanent dipole force. Now, if they ask you, let's see another type of question. Explain the difference in boiling points between bromine and HBr. So let's see, let's explain the difference in boiling points. And you know, boiling point depends on what? Intermolecular forces. Which factors depend on intermolecular forces? Boiling point, melting point, volatility, solubility, and physical state. So when they ask about boiling point, you have to talk about intermolecular forces. Now let's see. You have bromine and you have HBr. So let's take HBr and let's see which type of forces will HBr molecule have between it. So let's see, right here Br is more electronegative. So this will be partial negative, partial positive. There's a permanent dipole here. This is partial positive, partial negative, permanent dipole here. So between two HBr molecules, which type of forces will we have? We will have permanent dipole forces. And let's see what we have between bromine molecules. So in one Br, two with another Br2, which will have which type of intermolecular forces? Because this is a non-polar molecule, so this will have temporary dipole induced dipole forces. And which one is stronger? Permanent dipole forces. So which one do you think will have a greater boiling point? Bromine or HBr? HBr. Why? Because it has stronger intermolecular forces, which are permanent dipole forces, compared to bromine, which has weaker intermolecular force, that is temporary dipole forces. Clear? So you will say that HBr has a higher boiling point compared to bromine due to stronger intermolecular forces between the molecules. And what are the intermolecular forces between HBr molecules? Which type of forces do we have? Permanent dipole forces. So that is permanent dipole forces compared to weaker intermolecular forces between bromine molecules. That is, which forces do we have? Temporary dipole forces. Yes? So you say this has temporary dipole forces which are weaker, and HBr has stronger intermolecular force, that is permanent dipole force. Hence, more energy is required to overcome the stronger forces. That's why you have a higher melting point or boiling point. Yes? Hence, more energy is required to overcome strong intermolecular forces. Therefore, HBr has a higher boiling point. Clear? Is this clear? Yes? So you will say HBr has a higher boiling point compared to Br2 because it has stronger intermolecular force, which is the permanent dipole forces, compared to weaker forces that are temporary dipole forces in bromine. Hence, more energy is required to overcome strong forces. Therefore, HBr has a higher boiling point, and this usually comes for 3 or 4 marks. All right? Now, if they ask you another question, explain why the state or the physical state changes from chlorine gas to bromine liquid to iodine solid down group 17. So why does it go? They're saying from gas to liquid to solid. So we know physical state also depends on what? Intermolecular forces. The stronger the forces, the physical state would be solid. So if iodine is solid, can we say this has stronger forces? Now let's see the forces between chlorine, bromine, and iodine. So chlorine with another chlorine. Is chlorine non-polar? Yes. So which type of forces will it have? Temporary dipole. Is bromine non-polar? Yes. So which type of forces will this have? Again, temporary dipole. Is iodine non-polar? Yes. So which type of forces will this have? Temporary dipole. Now you'll be like, Miss, they have the same type of force. They're all temporary dipole induced dipole forces. So how can we say iodine is stronger? Let's see. You can determine the strength of van der Waals forces. In this, the van der Waals forces are permanent and temporary dipole forces. That's what I'm referring to. So you can determine the strength of van der Waals forces, which is temporary and permanent dipole. Their forces, their strength you can determine by two factors. One is the number of electrons. So the strength of these intermolecular forces, which two forces? Temporary dipole and permanent dipole forces. Their strength can be determined by the number of electrons and surface area. So the strength of these intermolecular forces is directly proportional to the number of electrons and surface area. The more the number of electrons, the more the number of electrons, the stronger the intermolecular force. Clear? And the greater the surface area, the stronger the force. So it is directly proportional to the number of electrons and surface area. Now, if you look here, chlorine, bromine, iodine, they all have the same type of force, but their strength will be different. And that will depend on the number of electrons. So let's see. Chlorine has obviously the least number of electrons because when you go down the group, the number of electrons increase. So you will say all three halogens have the same nature of intermolecular force. That is, which type of force do they have? Temporary dipole forces. So they all have the same type of intermolecular forces, which is temporary dipole, induced dipole force. But down the group, the number of electrons increase. Yes. Therefore, the strength of intermolecular force increases because strength of intermolecular force is directly proportional to number of electrons. So down the group, from chlorine to bromine to iodine, the number of electrons increase. And as the number of electrons increase, the strength of intermolecular forces increases. And since the strength increases, iodine has the strongest intermolecular force. Therefore, this is solid. Is this clear? And the weakest intermolecular force will be of chlorine because it has the least number of electrons. Therefore, it is gaseous. Is that clear? Yes. By surface area, I'll just show you the application of that. Now let's see another example. You guys tell me this. Explain the difference in boiling points between HCl, HBr, and HI. Which will have the strongest intermolecular force or the highest boiling point? HI. Why? Because it has stronger intermolecular force. Which force do they all have? They're all polar molecules. So they all have permanent dipole forces. But which one will be stronger? HI. Why? Because of more number of electrons. So all three have the same type of intermolecular force. And what is the type of intermolecular force? That is permanent dipole forces. But HI has the strongest intermolecular force due to greater number of electrons. Hence, more energy required to overcome the forces, and this will have the highest boiling point. So more energy required to overcome the forces. Therefore, it has the highest boiling point. And which will have the least boiling point in these? HCl has the least boiling point. And why is that? Due to weaker intermolecular forces, due to less number of electrons. Is this clear? Do you guys understand this? Okay. Let's now see another example. Explain the difference in boiling points of butane. You guys remember from organic chemistry what butane is? C4H10, it's an alkane. Butane, and its isomer, if you remember, 2-methyl propane. So let's see. I'm just going to draw butane and 2-methyl propane for you. This right here is butane, C4H10. And this right here is 2-methyl propane. This is also C4H10. They are both isomers of each other. Now, what do you think? Which one of these will have the higher or the greater boiling point between these two? Why? Because it has a greater surface area. Do you see? In butane, you just have CNH. In 2-methyl propane, also we just have CNH bonds. Does CNH have similar electronegativity? Yes. So both of these will have which type of intermolecular force? Temporary dipole-induced dipole, because they're non-polar. So because they have temporary dipole-induced dipole, now we will depend on their number of electrons and surface area to determine which one is stronger. They are both C4H10. So will their number of electrons be the same? Yes. Because this also has 4 carbon, 10 hydrogen, 4 carbon, 10 hydrogen. So number of electrons are the same. So now the strength will depend on what? Surface area. Do you see this has a greater surface area compared to this? Yes. So the greater the surface area, the stronger the intermolecular force and higher the boiling point. So you will say butane has a greater boiling point or a higher boiling point. So it has a greater boiling point due to stronger intermolecular force, that is temporary dipole forces, due to greater surface area as compared to 2-methyl propane, which has less surface area. Do you see that? Do you see the surface area is less? Now you will not talk about the number of electrons, because number of electrons for both are the same. So it has less surface area, therefore weaker forces. So this has weaker forces, hence less energy is required to overcome these forces, because it has less forces, less strong forces or weaker forces. So it is less energy required to overcome the forces, and therefore this has lower boiling point. And butane has a higher boiling point. Clear? Is this clear? Let's see this now. If I give you 3 isomers of C5H12. First one is a straight chain 5-carbon pentane. This is the first one, pentane. Then you have the second one, which is 2-methyl butane. And then we have the third one, which is 2,2 dimethyl propane. Let me give you these three isomers. 2,2 dimethyl propane. They are all C5H12. If I ask you which will have the strongest intermolecular force or the highest boiling point, and which will have the least, A will have the highest boiling point, then B, and then C. Why? Because this has the greatest surface area, then this, and then this has the least. Clear? So pentane has the highest boiling point due to strongest intermolecular forces. And why does it have the strongest intermolecular forces? As it has greatest surface area. Yes? Clear? And C will have the least boiling point. It will have the least boiling point. Why? Due to smaller surface area. Hence, weaker forces. Is this clear? Do you all understand this? And which type of forces will they all have? Temporary dipole forces. So they all have temporary dipole, induced dipole forces. Clear? Understood? All right, now we move on to hydrogen bonding. So let's see the third type of intermolecular force, which is hydrogen bonding. Hydrogen bonding is the strongest intermolecular force. So this is the strongest intermolecular force. Hydrogen bonding is a special type of permanent dipole force. So it is like permanent dipole, but it's a special type, and we'll see how it's special because it's not seen in all polar molecules. It's a special type of permanent dipole force found in specific molecules. It is found in specific polar molecules. Not found in all polar molecules, it is found in specific polar molecules. Now, for this, a criteria must be met. So you must meet two criteria for this type of intermolecular force. The first criteria is that your H must be bonded to an O, or the H must be bonded to an N, or H must be bonded to an F. So this is your first criteria, that H must be bonded to an O, it must be bonded to an N, or it must be bonded to an F. This is the first criteria. Only if you have these type of bonds will you have hydrogen bonding. The second criteria is that the electronegative element, which is the electronegative element in these bonds? O and N and F. So the electronegative element, that is O and F, must have at least one lone pair. So they must have at least one lone pair. In this case, hydrogen bonding will occur. So what is the criteria? Your H must be bonded to an O, to an N, to an F directly. And the electronegative elements must have at least one lone pair. This will give you hydrogen bonding, which is the strongest type of intermolecular force. And this strongest intermolecular force, hydrogen bonding, is a special type of what? Permanent dipole force. Let's see. So let's take an example of water. So you have water. Do you remember the shape of water? What was the shape of water? bent angular. So this was O with an H, a lone pair here and a lone pair here. Do you remember this? And I told you, despite the central atom having similar atoms around it, the molecule is asymmetric due to the lone pair. Lone pair disturbs the symmetry. We did that in Vesper theory. Do you remember that? Yes. And this molecule is polar, where oxygen is partial negative and the hydrogen is partial positive. Yes. Do you see there's a permanent dipole here? Yes. Let's take another water molecule. Let's take this another water molecule right here. Again, do you see partial positive end and partial negative end? And do you see this is a permanent dipole here? Now, let's see the first criteria. The first criteria was your H must be bonded to an O. Do you have an O bonded to an H? Yes. The second was the electronegative element must have at least one lone pair. Do you have that? Do you see electronegative element not only has one, but it has two? We need at least one. Do you have that? Yes. Can we have hydrogen bonding between this? Yes. Now let's see how we will show that. So hydrogen bonding will be an intermolecular force. Now, most often you guys confuse it with this. You're like, oh yeah, right here, this is hydrogen bonding. No, this is a covalent bond. Hydrogen bonding is an intermolecular force. It will be between two molecules. All right. Now let's see how you show hydrogen bonding. So hydrogen bonding will be from the lone pair of one molecule to the partial positive hydrogen of the adjacent molecule. So basically it will be the lone pair of this to the partial positive hydrogen of the adjacent molecule. This right here is your hydrogen bonding. Or you can also show it from this H plus to the lone pair of this oxygen. So you can show it like this or that. Either or is fine. This right here is the hydrogen bonding. And this you see is an intermolecular force. Do you see this is between two molecules? Yes. And this is a special type of permanent dipole force because there will be a permanent dipole in water. Yeah. But this is not specific to all polar. This is not found in all polar molecules. This is specific to a few which fulfill this criteria.
It's like dative covalent means the structure.
But in dative covalent bond, we form a covalent bond. This is just a force of attraction. All right. Why not what? No, because this is because these guys FON, they have very high electronegativity, so they can form hydrogen bonding. This is the criteria. You need these three with this. Only then can it show hydrogen bonding. Is that clear? So can we say that water molecule shows what? Hydrogen bonding. Can we say that? All right. So if I ask you to enlist all the types of intermolecular forces between water molecules. So let's enlist all the types of forces between water molecules. We will have what? Hydrogen bonding. What else will we have? Permanent dipole force, because I told you hydrogen bonding is a type of permanent dipole force. And what else will we have? Temporary dipole forces, because I told you those are found in all molecules. Yes. So you have temporary dipole, induced dipole forces as well. So you have all three types. But if I ask you which one is the strongest of these forces? Hydrogen bonding. Is this clear? So water is a polar molecule, and unlike all polar molecules which have just permanent dipole and temporary dipole forces, because of the criteria of hydrogen bonding being fulfilled here, water will also show hydrogen bonds. Clear? And if I ask you about the boiling point of water, it will be high. Why? Because hydrogen bonding, which is the strongest intermolecular force, will require more energy to overcome. and therefore boiling point will be high. Clear? All right, now we have a few more examples of hydrogen bonding, which we will continue tomorrow. Any questions?